that means you have a test next week. Okay, so keep that in mind when you're studying this weekend. The review's already posted on Google Classroom. But this is the last section. We'll do Tuesday 4.9b. Okay, Wednesday
4.7.
something, Thursday something, Friday something. There's a test in there somewhere.
Test Friday and 4.7 Wednesday and Thursday.
What's the test on?
Chapter 4.
Does this include you sub?
No.
God bless.
Yep. Okay, so if I should calculate a derivative, the derivative sign is
Cosine.
cosine x. Okay. But then I say, what is the antiderivative? Of cosine x. Yeah, it's sine x, right? Antiderivatives and derivatives are very friendly with each other. So friendly, in fact, we have the fundamental theorem of calculus in a couple weeks, right? That shows their relationship in a nutshell. So we're basically traveling backwards, if you remember that, right? Okay. The formal, so
No.
a function f of x is an antiderivative
I just realized you're still doing
of f of x on AB if big F prime equals little f for all x.
This is a memory card, isn't it?
I don't know if we made one with this on it.
Pretty sure it was.
Check when we get home.
Okay. So what is that saying?
That the derivative of an integral is the initial.
If you want to contextualize it. Yeah, you have an antiderivative. If you derive it, you get back to the original. Right. Okay. We could also say,
Yeah, all xt was the last one. The last bit of
what?
what does it say at the very end?
We're all
xt?
X, no, that's an epsilon.
Oh. I thought it was equal sign.
X is an element of the interval. Remember that? Epsilon E. So that means that for every X in this interval, that relationship holds. How else could we state that? Like, we have one way to state it. How else could you write it?
Big F x equals integral of f x.
You remember how AP writes it? Me either. Okay. Moving on. Okay, so those are the two ways you can really write it. I'll have to look up the way AP writes it. I remember every year. What did we not write on here?
plus C.
Yep. Okay, why do we need plus C?
Because that's the initial condition.
Because we could possibly have a number out here, right? And we don't know what that number is, but all constants have a derivative of 0. So we always have to include a plus C on the antiderivative because we might have a constant. Okay. All right. Do you remember the general power rule for antiderivatives?
N plus 1 over N plus 1.
Yeah. So x to the n plus 1. So add, divide by, right? General power rules, so we have x to the n plus 1 over n plus 1. As opposed to the derivative, which is multiply, subtract 1, right? So we have add 1 and divide, or multiply and subtract. Okay. So now, what's fair game? Oh. Man, stinking nose. Doo-doo-doo. Anybody remember?
Oh, natural log X.
You would say that, but you would be incorrect.
1 over X.
Natural log X plus C.
I don't think it's natural log X.
Doesn't make sense though, because it really
Say
is
something.
Is that reverse quotient rule?
No, it's something.
Oh, is it natural log X squared?
Search the memory banks. You're very close.
What the heck? Because the derivative of natural log X is 1 over N.
It is.
So the integral of 1 over X should be natural log X plus C.
Yep. What's the problem with natural log x? Is a domain issue. Where is natural log x not defined?
Negatives, so if that's the value.
Bingo. Don't forget your plus c. Yeah, so when we do the derivative, okay, this direction, we already know the x's are all positive because we're in a function that works, right? So the derivative doesn't need absolute value because the domain is already defined. But the integral, or antiderivative, has to add that absolute value because 1 over x possibly could have negatives in it. Okay? The weird thing is it actually works still, right? So
So
be careful with that. Okay?
they would want natural log absolute value X. AB would.
Oh yeah, definitely.
I'll just make my this straight-ish. Is it an absolute value?
All right, what about this one?
Isn't it just only X?
Yeah.
Plus C.
Plus C.
There you go. Okay. Okay, so those are our basics. You can do sine, cosine, all those, right? Those are all fair game too. Okay. What about something like this? kind of a chain rule question.
Sine 2x, or sine 2x plus 3 times x squared plus 3x.
I don't know where that is.
No, let's see.
No plus C, what?
Isn't it
Okay, what's the
negative
derivative, what's the antiderivative of cosine?
Negative
Sine.
Negative sign.
No, it's just.
No, it's just sine.
Are you sure?
Yeah. Because derivative of cosine is negative sine, derivative of sine is cosine.
Good. It's positive sign.
That means sine is negative cosine. Okay.
Is it times?
Okay, how do I deal with the 2x plus 3?
You integrate that as well?
Oh.
Now, if this were a derivative, I would get cosine 2x plus 3 times 2,
One.
right?
Yeah.
Chain
Oh,
rule
you divide it
problem?
by 2?
Over 2?
Over 2.
Ah.
Remember, you have to counteract the chain rule. Okay? So you can think in terms of derivatives and antiderivatives, it helps. Okay, same situation.
E to the x over 4 minus plus c.
E to the,
4x minus 1 over 4 plus c.
okay, yeah. So you're just counteracting the chain rule there, right? At its most basic. Okay, U substitution we get into is the chain rule for. This is bad. Oof. So, there you go. All right. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different antiderivatives. Right? We haven't written the trig functions down, but there are 6 of them. So, any questions? Okay. Off you go.
If it's two things multiplied by each other, you just antiderive them separately, right? Or I guess you could simplify that point with the way I'm thinking of it.
I am going to have to think that one through real quick. While
Because I was thinking like 9x, or no, because if it was like 9x squared plus, or not plus, but times 6x, would you just multiply them?
yeah,
Okay.
algebraically simplify.
And then if there's a plus, you just do it normally.
That's a lot of homework, sir.
Yeah.
Not really. You know, we didn't score the AP problems from yesterday.
That's fine.
Wait till tomorrow.
Is that 19 through 36?
Yes.
No.